Hello students, in this video we will discuss about factors and multiples. In the previous class we have studied the basic ideas about factors and multiples. In this chapter we shall review these ideas and extend our study to include some new properties. Here by numbers we could mean only counting numbers. Now recall the following definitions. Factor. A factor of a number is an exact divisor of that number. So, a factor is a number, or when a number divides another number exactly, then the divisor is called a factor. And the dividend is called a multiple of the divisor. Let us see some example. We know that 15 is equal to 1 into 15 and 15 is the product of 3 and 5. This shows that each of the numbers 1, 3, 5, 15 exactly divides 15, or 1, 3, 5, 15 are all factors of 15. Or we can say that 15 is multiple of each one of the numbers 1, 3, 5 and 15. For example, the multiples of 4 are 4, 8, 12, 16, 20. And the factors of 4 are 1, 2 and 4. Now we will see the various types of numbers. You already know about even and odd numbers, right? Even numbers are all multiples of 2. And odd numbers are the numbers which are not multiples of 2. Or you can say the counting numbers which are exactly divisible by 2 are called even numbers. For example, 2, 4, 6, 8, 10, 12, etc. And counting numbers which are not exactly divisible by 2 are called odd numbers. For example, 1, 3, 5, 7, 9, 11, 13 and so on. Now we will see the prime numbers. Each of the numbers which have exactly two factors, namely 1 and itself, is called a prime number. A number having exactly two different factors, that is 1 and the number itself, called prime numbers. For example, 7. 7 has factor 1 and 7. So, 1 and the number itself is called a prime number. A number having the factors 1 and the number itself called prime numbers. Okay. Composite numbers means a number having more than two different factors. Okay, more than two factors. For example, 4. See, the factors of 4 are 1, 2, 4. You'll get 3 factors, right? It is more than 2, so 4 is called a composite number. So clearly, I'll tell you one note, that is 1 has only one factor, namely 1 itself. And 1 is neither prime nor composite. See the important facts. 1 is a factor of every number, and every number is a factor of itself. And every factor of a number is an exact divisor of that number. And the smallest prime number is 2, and it is the only even prime number. And the number of factors of a given number are finite. The multiples of a given number are infinite. And every multiple of a number is greater than equal to that number. Twin primes. Two consecutive odd prime numbers are known as twin primes. Okay. See here, twin primes 3 and 5. Okay. Consecutive means serial numbers, like serial numbers, continuous numbers. Okay, for example 1, 2, 3, these are all serial numbers, right? So 3 and 5 are consecutive prime numbers. Okay, between 3 and 5 we get 4, right? 4 is not a prime number, so consecutive odd prime numbers are 3 and 5, right? Next, prime triplet, a set of 3 consecutive prime numbers differing by 2. Okay, as I told you, consecutive means continuous or a serial number, and it is differing by 2. Okay, here example 3, 5, 7, right? 3 and 5 differs by 2, and 5 and 7 also differs by 2, and 3, 5, 7 are consecutive prime numbers. Co-primes. Two numbers are said to be co-primes if they do not have a common factor, okay, other than 1. See 2 and 3. The factors of 2 are 1 and 2, and the factors of 3 are 1 and 3, and here the common factor is 1, and they do not have a common factor other than 1, right? Now we will discuss about divisibility test for each number. Test of divisibility by 2. A number is divisible by 2 if its ones digits is 0, 2, 4, 6 or 8. Okay. See the example. 30. Here at ones place we have 0. 0 is even, so 0, if ones digits have 0, 2, 4, 6 or 8, then the given number is divisible by 2. See 71. Here at ones place we have 1. Okay. That is odd, right? If the last digits is even, then the given number is divisible by 2. Next is test of divisibility by 3. A number is divisible by 3 if the sum of its digits is divisible by 3. Consider the number 64,275. Take the sum of all the digits like 6 plus 4 plus 2 plus 7 plus 5. So we get 24, right? 24 is divisible by 3. So the given number is divisible by 3. Now consider the number 39,583. Now sum of its digits are 3 plus 9 plus 5 plus 8 plus 3. We get 28. Is 28 is divisible by 3? No. So the 39,583 is not divisible by 3. Okay, if the number is divisible by 3, if the sum of its digits is divisible by 3. Next is divisibility test by 4. A number is divisible by 4 if the number formed by its digits in the tens and ones place is divisible by 4. Like if the last two digits are divisible by 4, then the given number is divisible by 4. Consider the number 96,852. Here the last two digits are ones and tens place have 52, right? That is divisible by 4, which is exactly divisible by 4. So that number is divisible by 4. Consider 61,394. Here last two digits are 94, right? So 94 is divisible by 4? No. So 94 is not divisible by 4. So the given number is not divisible by 4. Children, if the number is divisible by 4, if the last two digits are divisible by 4, then the given number is divisible by 4. Next is divisibility test by 5. This is very easy. A number is divisible by 5 if its ones digit is 0 or 5. If the last digit is 0 or 5, then the given number is divisible by 5. Next is divisibility test by 6. A number is divisible by 6 if it is divisible by each one of 2 and 3, or note that 2 and 3 are the prime factors of 6. Okay, children, in 6, we should see if the number is divisible by 2 and 3, then the given number is divisible by 6 also. Okay, it should holds with 2 and 3. Okay, so see here, you can see the example. Each of the numbers 18, 42, 60, 114, 1356. These are all divisible by each one of 2 and 3. So it is divisible by 6. Okay, if it is divisible by 2 and 3, then the given number is divisible by 6 also. Clear? Next is test of divisibility by 7. Test of divisibility by 7. A number is divisible by 7 if the difference between twice the ones digit and the number formed by the other digits is either 0 or a multiple of 7. Okay, consider 6804. Okay, here clearly 680 minus twice the ones digit, that is 2 into ones digits. At ones digits we have 4, minus 2 into 4 we get 672. 672 which is divisible by 7. So that the given number is divisible by 7. Okay, consider the number 137. Okay, here last at ones place we have 7. Twice the ones digit means 2 into 7, that is 14. 14 minus 13 is 1, which is not divisible by 7. Therefore 137 is not divisible by 7. Next is divisibility test by 8. A number is divisible by 8 if the number formed by its digits is hundreds, tens and ones places is divisible by 8. Okay, if the last 3 digits are divisible by 8, then the given number is divisible by 8. See the example, 79,152. Here last 3 digits are 152. Okay, that is clearly divisible by 8. So therefore 79,152 is divisible by 8. Consider 57,348. Here last 3 digits have 348, so which is not divisible by 8. Therefore the given number is not divisible by 8. Next is divisibility by 9. Okay, a number is divisible by 9 if the sum of its digits is divisible by 9. Okay, if the sum of its digits is divisible by 9, then the given number is divisible by 9. Okay, see the example, 65,403 and the sum of its digits are 6 plus 5 plus 4 plus 0 plus 3, we get 18, that is divisible by 9. Therefore 65,403 is exactly divisible by 9. Next, consider the number 81,326. Okay, sum of its digits are 8 plus 1 plus 3 plus 2 plus 6. We get 20, right? Is 20 is divisible by 9? No. So 20 which is not divisible by 9. Therefore the given number is not divisible by 9. Test of divisibility by 10. Okay, children, this is very easy. A number is divisible by 10 if its ones digit is 0. Okay, each of the numbers 30, 160, 690, 720 is divisible by 10 because the last digits have 0. So none of the numbers 21, 32, 63, 84 etc. which is divisible by 10. Divisibility by 11. A number is divisible by 11 if the difference of the sum of its digits in odd places and the sum of its digits in even places. Remember, here you should see the places, odd places and even places, not even numbers or odd numbers. Okay, you should see the places. Okay, see for example 90,728. Here sum of its odd places means 8, 7, 9 are in odd places, right? 1, 3, 5. So sum of its digits in odd places, that is we get 24, the sum of the odd places. Next, sum of its digits in even places we get 2 plus 0. Okay, 2 and 0, that is we get 2. The difference of the two sums are 24 minus 2, we get 22. 22 which is clearly divisible by 11. Therefore the given number is divisible by 11. Or if the sum of its digits in odd places and the sum of its digits in even places is 0, then also the number is divisible by 11. I hope you have understood the divisibility tests and prime numbers, composite numbers, even numbers, odd numbers, factors, multiples. Okay. In the next video, we will discuss about prime factorization, HCF and LCM.